This video is a continuation of video tutorials on civil engineering materials lab experiments. I am Usman Javed. I will be teaching you different lab experiments of civil engineering materials. So in this video we will learn about the water absorption, moisture content, and bulk density of a fine aggregates. Basically, the fine aggregates might be the sand in major cases. In most of the cases you use sand, which is classified based on their particle sizes and their composition. Sand contains a high amount of a silica, which is crystalline in nature. So the sand which is taken from any riverbed or any other source have some sort of a water absorption associated with it due to its smaller particle size and due to its some attribute physical characteristics like bulk density. So for this experiment we will be having picnometer, a blower dryer, a sand sample, and cone-shaped metal mold in which we'll compacting the sand with the help of this metal tamper. So how we can get the specific gravity, water absorption, and uh, bulk density of this material sand. So basically, specific gravity, if we define the specific gravity, is basically the ratio between the two densities, the ratio between the density of a material to the ratio to the density of water. If we talk about the bulk density is the density of a material including all the bulk volume. Bulk volume might have some pores, some air voids, some water incorporation. So the bulk density includes overall density of a material including all the components present in it. Moisture content is basically the amount of water present any specimen is moisture content. Water absorption is there is a difference between the moisture content. Moisture content is totally relevant to the absorption of an aggregates which are taken, the water uptake or water absorption from the atmosphere. On the other hand, the water absorption is basically the SSD absorption. SSD absorption is the saturated surface dry absorption. Saturated surface dry is the term used for the material which are in itself saturated but dried on its surface. Like we have a fine aggregate sand. If we convert it into the saturated surface dry condition, it must not have a water on its surface. If we touch the fine aggregate, it must not stick to our fingers or hand. If it do so, it means that it has an adequate amount of water present at surface. So you must have to remove the water present on its surface using the blow dryer, so that its surface might be dried but the inner pores must not get dried. So this condition is known as saturated surface dry. So according to ASTMC128, we have um, this standard procedure for for specific gravity, relative density, and water absorption of a fine aggregate. You must have to get to know about the definition of these entities like density, the mass of oven dried specimen per unit volume is density. Obviously, everybody knows about it. Being an engineering student, you must know it. SSD, I have already mentioned that saturated surface dry condition in which the pores have adequate amount of water but the surface is dry. Apparent density is the mass per unit volume of the impermeable portion of aggregate. So it's apparent density. Oven dry is basically condition or a bone dry condition in which the material is dry up to 110 degrees Celsius plus minus 5 per 24 hours to get a constant weight or to get a constant weight. For example, you have a specimen you are heating in an oven. Uh, the weight difference between the interval must not exceed by 1%, it means the weight loss is almost a constant. If we draw the curve between the weight loss and the time, the curve must be stable at some instant of a time when while heating at 110 degrees Celsius. So that constant weight must be taken as oven dried weight. So all these definition, you must have an idea about it before you conduct this test. So the summary is basically you first have to immerse the sample for enough water for 24 hours. Then you just remove the sample and try to convert it into SSD form. When you convert it into the SSD form, then you will take your sample and insert in it a picnometer and take different weights. So how can we get an idea that the aggregate is an SSD form or not? So it's a very basic thing that you must know, that the the sand particles are being surrounded by the water molecules, water layer that makes to stick with each other so that it form a shape. When you remove the cone by making this shape with the sand, the volume must retain. The volume must be retained due to the presence of water onto the surface of sand particles. When the water is not present on the surface of a sand particle, it means um, it would not retain its shape. So the point is, you will remove the water layer present on surface of a sand particles so that it can be converted into saturated surface dry condition. For that purpose, you will blow your sand sample with a blow dryer so that it can not fully retain the shape of a cone after removing it. So it means it have gained the saturated surface dry condition. When the sand has gained the saturated surface dry condition, you will take the sample from the sand. You will take around 500 grams of a sample and put it in this picnometer, which is partially filled with water, and then level it up by inserting the more water so that you can have the leveled picnometer surface. You will just weight this picnometer along with water and sand sample, and then you will weight picnometer and water picnometer and water on weighing balance, uh, and lastly you will weigh the picnometer uh, emptied weight. So by computing into the formulas, you will calculate the density of a liquid. Here are the formulas that relative density oven dried form. A is basically oven dried sample. You will take the sample when it's SSD condition. You will place it in oven for 24 hours at 110 degrees Celsius plus minus 5. After 24 hours, you will record the weight loss. The the weight loss would be the water absorption, which is this one. And water absorption is basically the saturated surface dry minus oven dry. A is basically oven dry sample divided by oven dry. You will get the water absorption. C is basically the mass of picnometer filled with specimen and water. For the apparent density, apparent relative specific gravity, you must have a oven dried sample divided by mass of picnometer filled with water plus mass of a saturated specimen and minus mass of a picnometer with specimen and water. In this way, you can calculate the oven dry specific gravity of a fine aggregate. For saturated surface dry condition, because in concrete you use the saturated surface dry condition, so you must know the saturated surface dry specific gravity of a specimen. For its calculation, you must have a water absorption and along with specific surface dry condition, specific gravity. So in this formula, which is basically the absorption plus 1, I mean, for example, the uh, fine aggregate undergoes 2.3 value of water absorption, it would be like 1.023 multiplied by this specific gravity. So you will get the SSD form of specific gravity. So you must keep in mind that oven dried specific gravity would be always less than the saturated surface dry specific gravity, because the aggregate present in the concrete mix would be in saturated surface dry. So in order to have an idea about the saturated surface dry specific gravity, it's important to use this formula to calculate it. And this calculation of a specific gravity in SSD form would be used for calculation of mixed constituents in mixed design. So how can we practically calculate it? Let's have a look. So first you fill the water up to the this mark, and up to the this mark you will weigh it on weighing balance. You will all the precaution do the precautionary measures. You will clean it down. You will remove all the excess water. You will weight the picnometer and water. Then you will remove the half of the water and insert your soil sample. Make sure that your soil sample would be in SSD form. If SSD form is form at which we assume that it is in SSD form, it exists in the cement paste, in which no water is contributed into the aggregates or contributed by the aggregates into the mix. The moment you will get the saturated surface dry condition, it would be, for example, here is not a SSD. I think aggregates are a little better than in SSD. You will again remove the excess amount of water so that the slump retention, the cone retention would not be. In the here is you have over dried the specimen so that there is no cone formed. So you have to sprinkle a little amount of water and allow it for 30 minutes so that it can have absorb the water into the pores. So then try it again for making the this mold. After compaction, you will remove it. If it have retained the shape, it means it have got the SSD form. So this is a SSD form in which a few of the material has been detached and the few partially cone is retained. So you will add the SSD form aggregates into the picnometer. The 500 grams of SSD weight into the picnometer, and after adding the 500 grams of a picnometer fine aggregate into the picnometer, you will take the SSD weight of a specimen and keep it for water absorption into the oven for 24 hours at 110 degrees Celsius, so that you can get the water absorption of this SSD aggregates, fine aggregates. You will place it in oven after 24 hours at 110 degrees Celsius. After 24 hours, you will get the water absorption. On the over here, the SSD weight of a fine aggregate have added into the water, half liter water, and then you remove the bubbles, any sort of bubbles present in it, so that it can give the accurate result up to this marked value. After doing so, you will add a little more water so that it will reach up to the leveled mark. You must ensure that it would be at 27 degrees Celsius, 73 Fahrenheit. Uh, 27 degrees Celsius, 73 Fahrenheit. Uh, 27 degrees Celsius, 73 Fahrenheit. 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 27 degrees Celsius, 73 F you will note the lower meniscus of water at this point and then weight the specimen. Now clean it as a precautionary measures in order to avoid the excess of water present on it attached. Then record the weight of picnometer, water and sand sample in SSD form. So this was a brief experiment that you can conduct to get the overnight weight. After 24 hours, you will get the overnight weight by uh, by the formula of SST weight minus overnight weight divided by overnight weight. That this is the formula, and 200 to get a percentage. C is the mass of picnometer, water and sand sample. S is saturated surface dry condition, fine aggregates. This formula would be used to calculate the specific gravity in overnight, and this is so implications and interpretations for by calculating the in a bulk density, specific gravity, and water absorption, you'll have an idea about your aggregate. Either your aggregates are a normal weight, heavy weight, or you will guess about the water absorption of a fine aggregate, so that you cannot incorporate the excess amount of a water. So to avoid any flooding in concrete, so that the undesired properties like shrinkage and bleeding effect can be minimized in concrete. So it's very important to have accurate water absorption and specific gravity of aggregates for a calculation of a mixed design constituents, or in order to estimate the quantity of a fine aggregate present in the mix. I hope you have learned a lot about this lecture about the specific gravity. In case of any confusion, you may ask in comment section. Thank you for watching this video.